So the last time we set up our database using MAP. MAP is software that runs MySQL Server, so it needs to be running during this as well, because MAP is going to be running our database, and then we're going to also run our test code here. It's running, but I'll start it again. nodemon index.js. Index essentially being the entry point for our Node Express application. It, in turn, is going to use MySQL Server in order to provide the data that we're requesting. So now we essentially have two servers running in our system. The MySQL database, which is providing our database requests, and the Express API, the music API, that's acting as an intermediary to provide that database information to our client application. The next client application that we create in terms of software writing is going to be an Angular application that exercises the music API. Before we get that Angular application running, though, we need to understand a lot about Angular and write actually quite a lot of code. So it would be nice to be able to test the API in advance of that. That is, make sure our API is working before we run our client code, and also that the people who are writing the client code have full understanding of how the API works. Postman is a great tool for that. It's a great tool for not only testing the API, but also for figuring out how it works, because you can see it right in front of you. It's client code. It's going to connect to our music API and make requests the same way we're going to make requests when we write our Angular code or our React code. It's a client too. It's talking to our service for our data service for music API data. So our database is running and our API are running. We're ready to test a few of our entry points. Let's take a look at index.js, which is really not only our main, but where our entry points are defined in terms of the routing. So we say app.get the root route. That is the very first route in our application. Since that is a get operation, we can actually test that in our browser. Localhost 3000, where our API is listening, and we can show this is our default route. This is the response of the root route, that is here. We can see the response of artists here. So that's with the URL artists as well. So it's going to follow that path and respond with the artists that are known in our database right now. The Beatles and the new Beatles. You probably don't have the new Beatles. I created that later on. But here are the artists that are known in our database, and that's a response to this code right here. So gets can be exercised or tested in the browser using the URL tab, because that's what the URL does. It does a get operation, a read operation. Think about it. You're reading web pages using that by entering the artist, by entering the address of the machine, and then the path of whatever data resource you want to look at on the web, and that's working this way. So I've shown you two gets from the browser's perspective. Let's see those now set up and working in Postman. So I run the Postman user interface. Now you're not going to see this. I have several collections here. So I like to organize my API testing in collections. In fact, I already have a collection for our API here too. But I'm going to show at least a couple of entry points from the creation perspective, from brand new perspective, and then we'll probably go ahead and explore the rest of this API that I've already developed here. So go over here, new, actually new up here, a new collection. So I'm going to call this new collection 391 demo. Okay, and then within that collection, I'm going to actually make requests. So here, I want to actually add a request. Now that opens up here with a get verb. We've talked about the HTTP verbs, and they're all here. The verbs that we need to use, and we'll exercise all four of them by the end of our demonstration here. So we have a get, and then we need the URL. So that, remember, is HTTP : the protocol, HTTP protocol, localhost 3000, and then the root request, and we send the request. This is the default root. This is the same thing we've seen in the browser. It's very simple to write, in fact, GET requests. The GET verb and normally just the URL. We can give our API a meaningful name here. Get the root. So API get root. We can create a brand new request, or we can duplicate what we already have. So I'll duplicate this. And I'm going to turn this into get artists. Okay, we'll call it artists. We're going to get here, enter the URL here. And we'll have, this has already been typed in here for me. So I'm going to do localhost 3000 artists and send. And we have the names of the artists that are known in the database right now. As we create our names and give them meaningful requests, meaningful names, we can save them. And you can see there's a tabbed interface up here. It's a little bit pale here, but that is a tabbed interface, and we can save all of our requests. I'm going to right-click on a tab here and close all tabs, so get a fresh interface here. And we'll see the root request and the artist request that we've created. Those are all GET requests, and now we're just going to go to the GET requests that I've already created. Expanding my collection music API 391, we can see all of the GET requests defined here. Get artists, get albums, and all of the action is in the URL. The get verb, and then what we want to here, and that's matching our route requests over here. So get albums and get artists. These are the function that goes that in the music DAO that fulfill that functionality. This route is matched, and this callback function is then executed. This request is a little different. We have a colon here, artist. This turns artist into a variable name. So part of the URL, the get URL, is not changed, but this part of the URL is in fact a variable. So albums, The Beatles, would be the albums from the artist, The Beatles. And you can see how this variable name is picked up and used here. Down in here, request.params.artist. This then is the GET request that exercises or tests this entry point here. The Beatles becomes the value of the variable artist. Okay, so these are artists. These are albums found by the artist Beatles, most of the database. If we enter in, let's say, a username, a band that doesn't exist, I'll just put an X on the end of the Beatles, and we can see a proper response is an empty album list. No albums have been found for that artist. The new Beatles is an artist I created, so we should be able to see an album from that, Revolver 2 by the new Beatles. The new Beatles are not that creative, evidently. So this shows how a normal-looking URL can be used to define a variable in our Express application. The other place where that syntax is used, one other place, is search. So album, search, artist, and then a search term. So here's a test to exercise that. Album, search, artist for the term the. And you can see it appears in several places, of course, in the artist name, The Beatles. Right? So if we change that to something that's not found, Dex, no, we have no results. It's a proper return. It's not an error. No results contain the search term Dex. The description search works the same way, except that it's coded to search the term in the description text of the database. And here we have two variables. Search on albums, the artist, and the ID are both variables. And here we see the test URL for that, developed in Postman. The albums, the Beatles, search for album number 6. And there is the ID number 6, A Hard Day's Night by the Beatles. Next, we'll look at the delete requests, which in our application's case are written a lot like the GET requests. That is, all of the information is contained in the URL necessary to carry out the delete. So the mechanisms are the same, really. The verb is different. It's the delete verb. We're going to delete an album. We're going to delete albums, the Beatles, ID number 1. You can see that the way this is implemented, it doesn't have to be implemented this way, but in this case it is. We're implementing as a variable here, artists, and then ID here. So this would, if it succeeds, we'll take the Beatles ID number 1 and delete it. Notice app.delete matches the delete verb here. Let's send that request, and we can see delete album failed. I've already deleted that album, in fact, so it's already gone. I'm going to go ahead and run the database creation script again, and in order to put the database back into its original condition. So again, I added the line drop database if exists music at the start of my script. You might want to do the same thing. It's convenient. You wouldn't want to put this in production, but for our test cases, it destroys the database and then recreates it. So now when I do get artists, the new Beatles are no longer there. That was a change I had put in later. And also delete album should also work too, because delete album is in fact in the database. Now if I send it again, the Beatles album ID number 1 is no longer found, and so that's why the delete album found. That's a perfectly appropriate and correct working response. I can delete some more albums as well. Let's see if they have to match the IDs. And of course, every time you want to run your database to destruction like this, you can run that script again and recreate it for the next time. Okay, I'm going to write a post from scratch. It's a little bit tricky to get a post. A post is a write operation, so that means I have to get the syntax of the album correct. So I'm going to do that from scratch to show you the process of writing a post. So in the 391 demo, which I have the 2 gets here, I'm going to create a new request. And they wake up as get verbs, right? So this is going to be post a new album. We don't have to use post. Let's say create a new album. Okay. And it's post. Let's take a look at down here for the clue for the URL. And we find our URL is actually very simple. It's a post albums function. Let's do that. Post albums. Just like the get, except with the post verb, and that's proper REST API design, recall. Plural album, and the verb tells it what it's going to do. It shouldn't be in the name of it. And we should already have the idea that this is not going to work because where's our album? We haven't defined it yet, but let's try it. Invalid album posted. So my post request is posting an invalid album. I haven't added any album information. That goes actually in the body of the post. So previously, all of our information has been in the get URL. Typically, that's true for get. It's a read operation. What resource do you want to read? But for a post, we need some more information, and in fact, we need a body here. Now, the body is going to be classified as raw, and then we're going to put JSON here. Now, to get the exact JSON format might require me some effort here. So I added a get to read the albums here, in order for me to get an idea about what a properly formatted album here is. I'm gonna cheat a little bit here, and I'm gonna just copy this one Beatles album here, and we'll see about getting that going. Okay, so what I did was find a single album in the read albums. The curly brace helped me here, and I just posted it to see what happened, and it worked. Now we're gonna have to take a look at how it works. Look at the album ID of 15. So we're specifying album ID of 4, which if you know databases, If it tried to write the album with the ID of 4 again, it would probably be a primary key constraint. That 4 is unique across all the albums for this artist. So the database is evidently creating a new album ID for us and ignoring the ID that we're specifying here. So this is JSON data. That's JavaScript object notation. We see curly brace here, a curly brace here, and within that are key value pairs. When you see this syntax here, this is the syntax for an array, and then that array contains objects within it. Okay, so objects, just as in Java, objects can contain objects. Objects can also contain arrays. Here we have the named array tracks, and within that we have objects as well. And then we have data types of integers and strings. So key value pairs. So I got the idea again about how to create this album from the syntax I got from reading the album. Right? I simply copied that one album, and it worked. Now, when you post it, of course, it's posting the same album information over and over again. Let's take a look at what that looks like in the database. So I look at albums. I'm going to right-click here, select rows, and that gives me a query with all rows and all columns. And we can see our creation of album 1415. Every time I push that button, it recreates this album here. So if you want to, it also creates an artist, the Beatles. So different artists are reported different ways. This won't create a new artist. Artists are created kind of in a backhand way. That is, if I called this the Beatles right now, let's look at get artists here. And we have the Beatles because that's the unique artist that were created. But the artists are read by reading the albums. And then unique artist lists are made from that. So if I create a new album, and this time I'll change this. Don't change anything else. But this will be registered as a new artist, or essentially thought of as a new artist. It goes in the artist database, but now when I read artists, we can see that we have a new artist created here, the new Beatles as well. Okay, so that's how you do a post. Let's see how you do the next thing we'll need to do, and the last thing we'll need to do is the put, which is the modification of an album. This put should modify album 14 and give it the title Revolver 2 and the new Beatles. Notice over here, it's Please Please Me Right Now by the Beatles. So we'll run this send. We updated album number 14. We'll request that query again. Album 14 is now called Revolver 2. We changed the artist as well, and some other things about the album. So the idea, whenever you write the put, it's very similar to the post. It's sending information to the server. But at this time, we saw that the post ignores essentially the ID that is being sent. It creates a brand new primary key. But in the case of the put, the edit, it believes in the ID, and it modifies, and any other property that's changed in here will be modified accordingly in the database. So that's the put request. So we've gone over all 6 gets that are defined in our API, as well as the post, the put, and the delete. Thank you.